Hi everyone, this is Brent with Lab M12 at Texas State University, and today we're going to walk you through how to efficiently train, inference, and evaluate MaskRCNN on COCO formatted datasets. If you're not familiar with MaskRCNN, we'll leave a link to its paper in the video's description if you want to learn more about kind of how it works, sort of its underlying architecture. But for the purposes of this video, we're not going to explain what's happening under the hood of MaskRCNN, but instead keep it more high level and teach you how we conduct research when training these models. So just how to use it as a tool for what it's made for, right? We'll be walking you through how to remote into a GPU cluster, set up that cluster's environment for working with MaskRCNN, and then how we can access a Jupyter notebook from our local machine and interface with MaskRCNN that way. So let's go ahead and remote into our server right now. So I'm going to open up an iTerm instance and SSH into our GPU cluster on campus. Cool. So I'm going to change directory into my tutorial folder. And this is the dataset that I'm going to be using. So if I go into my dataset, I have, it's basically a bunch of satellite imagery over the city of Austin. And it's split up into a train, test, and validation set in the COCO style format. So if I do tree-l, let's go down 2 layers. Then we can see that I have my annotations file and my images folder. And so basically whenever we start our MaskRCNN model, we'll basically tell it, here's my annotations file, and here's the images that I want to pull from. And then it'll start doing its thing in training. So whenever you first go into your GPU cluster, if you haven't done this already, you need to have NVIDIA Docker already installed on your system. And this is because whenever we launch our Docker container that facilitates MaskRCNN and all of its dependencies, we're going to have to specify what's called a runtime flag. And the runtime flag is going to be the NVIDIA runtime. So if you don't already have NVIDIA Docker installed, go over to their GitHub page, which will also be linked in the video's description. Scroll down until you find your particular version of Ubuntu or Linux that you're dealing with. In our case, we're doing Ubuntu 18.04 Bionic Beaver. So I would take these commands and type them in, and in most cases, it'll install correctly. In the case that it doesn't, you may have to reload the daemon and then restart Docker, and then your runtime will probably be recognized. So I'll also link this GitHub repo in the description. So once you have that installed, go ahead and clone our MaskRCNN Jupyter suite. This is an in-house tool, or a set of in-house tools that we've written for our lab that we use to efficiently train and evaluate models. So we'll go to clone or download, copy the link, and then git clone into our repo. And so because I already have my dataset inside of this dataset folder, I'm just going to do move datasets into MaskRCNN Jupyter suite, and then cd into that folder. So now I have a couple files. I have my datasets, evaluate, inference, train, as well as some other tools that we've used, as well as my Docker folder. So if you come over to the repo, it says to cd into Docker, and then we need to build the container. So we're going to build it with the name MaskRCNN just to keep it independent and discrete. So we build this, and we're going to let it run, do its thing. It's going to install all the dependencies that we need, such as libcuDNN, which is the kernel that basically allows for TensorFlow to communicate to the CUDA cores under the hood for your graphics cards. Awesome, so we've built our container, or our image rather, and so if I do Docker images, then I can see that we've in fact made our MaskRCNN image. So let's go ahead and activate that image so we can actually start working with MaskRCNN and set up our Jupyter notebook. So if I go back one level, and then let's copy this command, and I'll explain kind of what's going on. So we do docker run, and then this is where we specify the runtime flag, which is NVIDIA in this case, and this lets us use NVIDIA Docker for our container. We're going to expose port 8888, which is important because we'll be accessing that port on Zvezda whenever we access our Jupyter Notebook. This port could really be anything, just so long as you expose a port on your Docker container so that you can access the Jupyter Notebook on your remote server. In the case that you're working locally, this really doesn't matter, but for our purposes, I just want to explain how you can, in fact, access a local or remote server and do this kind of work. We're also going to mount our current directory as a volume so that if anything actually happens to our container, we won't lose any information. And that's really critical because, especially in the case where you're using, where many people are using the same server, you know, sometimes that can get kind of hairy and you don't want to lose any information that you don't have to. And then we're going to go into it in a bash setting so that we can interact with it a little bit more fine-grained, you know. Cool. So now we go into the home directory, and we still see all of our files here. So now what we're going to do is we're going to create a virtual environment. So virtual env was already installed whenever we set up our Docker environment. So we do virtual env-p python 3 venv. And this will basically create a virtual environment called venv. We can then activate that virtual environment, and we can also install Python and NumPy. And the reason we do this before doing pip install from the requirements file is because whenever you install pip dependencies from a requirements.txt file recursively, sometimes there are larger dependencies that are invoked, right? And if you don't have those dependencies, then the whole installation will crash. So in our case, we need Python and NumPy before we do pip install-r requirements.txt. Awesome, so we have our Python dependencies installed, and now we can actually activate our Jupyter Notebook. So if we type in Jupyter Notebook --IP, and we set IP to 0.0.0.0, this basically allows for our Jupyter Notebook to be accessed across a network, which is important for us because we're accessing it on a Mac. So expose the port to also 8888, and then we are running as root because we're in a Docker container, so we have to do allow root and then no browser. So now our server's up and running. We're going to take this authorization token and copy that because we'll need it here in a sec whenever we try to get into the notebook. So if I go over to my server at port 8888 and then paste in that token, then now I'm inside my notebook and I can start training my models. So thank you everybody for tuning into this. This is the end of part 1. Part 2 will be actually training our model, and then part 3 will be inferencing, followed by evaluating our model, how well our model performs per se. So we'll see you in the next video. Thank you.